Hello everyone, welcome back to chemistry class. I am Bhagyalaxmi, Assistant Professor, Department of Chemistry from Marri Laxman Reddy Institute of Technology and Management. Today we are going to discuss about external treatment, ion exchange process and also reverse osmosis. In this video lecture on external treatment ion exchange process, this is Engineering Chemistry Module 1. External treatment. What is mean by external treatment? And ion exchange process, it is also one of the method for this external treatments. From this external treatment, removal of all the impurities, all the hardness causing also from this hard water is called as the external treatment method. Means hard water make it into the soft water is called as external treatment. So ion exchange process, it is also this one of the method for this our external treatment, because in this external treatment ion exchange process, removal of complete ions from this hard water is called as ion exchange process. Completely removal of all the calcium and magnesium ions from the hard water, make it into the soft water or purity of the water from this process is known as ion exchange process. This ion exchange process, it is also known as deionization or also known as demineralization, because all the removal of all ions from this water or all the removal of this all the minerals from this water, so hence it is also known as deionization, demineralization process. So what is the principle involved in this ion exchange process? In this ion exchange process, exchanges of the ions takes place in between the stationary phase and mobile phase. That means mobile phase means it's a liquid phase. So this exchanges of the ions, all the cations and anions can be exchanges, removal of the hardness causing salts of these anions and cations, and make it into the pure formation of this water from using of this our ion exchange process. In this ion exchange process, we are using ion exchange resins. So ion exchange resins are insoluble, cross-linked, porous, high molecular weight and organic polymers, which is consist of the functional groups, acidic functional groups and basic functional groups. So based on this our attachment of this our functional groups acidic and basic, we are using, they are the two types of the ion exchange resins. First one is the cation exchange resin and the second one anion exchange resin. So this ion exchange resins, cation and anions are polymers, organic polymers, insoluble microporous structure of the organic polymers. In this process we are using. So two types of the resins, cation and anion exchange resins. So cation exchange resin, anion exchange resins. So first one, what is cation exchange resin? So this is the structure of the cation exchange resin. Cation exchange resin, polystyrene attachment with acidic functional groups. Attachment with acidic functional groups like sulfonic acid or acetic acids. So strongly acidic acids or weakly acidic acids are used in this cation exchange resin. So polystyrene, it is a polymer. So this is the polystyrene. Benzene with attachment of the CH2, CH2, it is nothing but polystyrene. N number of styrene to form this polystyrene. So n number of polystyrenes with our acidic functional group, sulfonic group or any weakly acids group, we are using in this our ion exchange process as an cation exchange resin. Then second one is the anion exchange resin. So anion exchange resin, it is also attachment of the polystyrene with the basic functional groups. So polystyrene attachment with basic functional groups, strong basic or weak basic functional groups. So this is the our polystyrene molecule. So n number of polystyrene molecules or attachment with our basic functional groups like ammonium hydroxide or any sodium hydroxide. So we are attachment with our polystyrene. So this type of anion exchange resin is used in this ion exchange process. Ion exchange process, we are using two types of the resins. One is cation exchange resin and second one anion exchange resin. This is the image. This is the process. We observe this using of this ion exchange process. So here in this ion exchange process, we are using two types of the chambers. One is a cation exchange resin chamber and second one anion exchange resin chamber. So this cation and anion exchange resin chambers are kept alternatively. And in this, we are using the hard water, make it into the soft water process. So this is the image we observe this ion exchange process. So this is we are called as a cation exchange resin chamber and this is the anion exchange resin chamber. So first hard water is passed through on our bed of the cation exchange resin chamber. In this cation exchange resin chamber, cation exchanger is there. So this cation exchanger is interacted with this our hard water causing salts like calcium and magnesium ions. So here for example any CaCl2 is there in our hard water. So Ca plus 2 is cations. So these cations are exchanges and releasing of the H plus ions in this our cation exchange resin chamber. And this water passed through this our second chamber, anion exchange resin chamber. In this anion exchange resin chamber, it will be consist of the bed anion exchanger. So in this anion exchanger is interacted with these anions like Cl2 minus ions, Cl minus 2 ions, then here 2 Cl minus, okay, or ions can be interacted with this our hard water, our anion exchanger, then releasing of the OH minus ions. So here in the first chamber releasing of the H plus ions and from the second chamber releasing of the OH minus ions. So combined H plus and OH minus ions to produce the H2O. This is our purity of the water or softening of the water. So this pure water or softening of water we have to collected in our 1D mineralized chamber, that is our third chamber. If we want, then we can use one more chamber, that is the demineralized chamber in this process. So here in this we can make it into this from make it into the pure water from using of this our cation exchanger gravels and using of the anion exchanger gravels. So what type of the reactions will be takes place whenever we are using of this hard water into this ion exchanger process? We observe this. What type of the reactions or mechanism will be involved water softening of process? So first cation exchange chamber. So this cation exchange resin, here it is also known as RH plus RH plus. This RH plus cation exchange resin is interacted with the calcium ions to form the alkyl calcium plus 2 and releasing of H plus ions, For example, any magnesium ions will be present in our hard water. So our cation exchanger can be interacted with this hard water of magnesium salts to produce this alkyl magnesium ions, exchanges of the magnesium ions and releasing of H plus ions. So here it is in the releasing of H plus ions from our first chamber. So this water, then acidic of the water with our anions can be passed through this our second chamber, our anion exchange resin chamber. So what is the anion exchange resin? ROH minus. This is we are called as anion exchanger. Cation exchanger is RH plus, anion exchanger is ROH minus. So this OH minus anion exchange can be interacted with the anions from this our hard water to produce this anions with alkyl groups and releasing of the OH minus ions. If it is the presence of the any chlorides, sulfides or any bicarbonates are also will be there. So bicarbonates can be formed as a alkyl group of bicarbonates and releasing of the OH minus ions. So from our first chamber, cation exchange resin chamber releasing of H plus ions, and from our second chamber releasing of the OH minus ions. So combination of the H plus and OH minus to get or to produce this our water. At the end of the stage, end of the process, we will getting of this our softening of water from our ion exchange process method. So these type of the reactions we observed in our ion exchange chambers. And here we observe this regeneration of the ion exchange resins. Why we are using this regeneration of exchange resins means these are very cost. So hence we are using this again the regeneration of this our using of resins. Okay, then regeneration of the cation exchange resin. Cation exchange resin is regenerated by the addition of the acids. It's like diluted HCl or H2SO4 to produce again our RH plus. RH plus it is nothing but cation exchange resin. Okay, so regeneration of the cation exchange resin with addition of the acids that is HCl or H2SO4. And anion exchange resins are regenerated by the addition of the bases or alkalis like sodium hydroxide. So the sodium hydroxide interacted with this our alkyl anions, then again to produce this our anion exchange resin. So regeneration of the anion exchange resin with the help of the sodium hydroxide. So these are the regeneration process of the cation and anion exchange resins. Then what are the advantages of this our ion exchange process? This process make it into the soft water. Almost all the ions can be eliminated, means purification will be there. So the hardness, very low hardness is there. So very low hardness is equal to 0 to 2 ppm. That means almost all the hardness causing salts can be eliminated from this our ion exchange process. So this water we can use for the domestical and industrial process, and this method we can be used in the high pressure boilers. And also we can use this highly acidic or also the basic water components in this ion exchange process. What are the disadvantages we observed whenever we are using this our ion exchange process? So this setup it is very costly, and the ion exchange resins, the chemicals it is nothing but ion exchange resins. So ion exchange resins are also the very cost. So hence we are using this again the regeneration of this our anion and cation exchange resins with the help of acidic and basic agents. And this water should not be turbid, and turbidity level should not be more than the 10 ppm. So this is also one type of disadvantages of this our ion exchange process. So this is about our topic today we discussed in our session. So in this lecture we are discussed about external treatment ion exchange process, and engineering chemistry water and its treatments module 1. Again last topic is the reverse osmosis. So what is the reverse osmosis? So before going to this our reverse osmosis, first we have to learn about what is the desalination. Why? Because this is one of the method for this our desalination process. So what is desalination? So desalination means removal of salt from the water is called as desalination. Removal of salt means NaCl ions, sodium chloride ions, Na plus Cl minus ions from the water is called as desalination. So in this desalination means we are using this our salt water. We can remove all of these ions from this water. So they are the different types of the water will be there. So what type of the different methods, different types of water is there? One is the fresh water, second one is the brackish water, third one is the sea water. Then in this presence of the dissolved solids. So based on this or depending upon this our quantity of the dissolved solids, we graded of this our water. It's like a fresh water, brackish water, sea water. So here this fresh water, it contains the less than 1000 ppm of the dissolved solids. Brackish water more than 1000 ppm to less than 35,000 ppm of the dissolved solids. Sea water more than 35,000 ppm of the dissolved solids. So we can use this different types of this water like fresh water and sea water. So these two different concentration of the solutions we are using, then removal of the salt from this our water. So this is one kind of desalination method. So in this desalination, actually the reverse osmosis process is there and electrodialysis it is also there. So in this video lecture on reverse osmosis. So let us discuss reverse osmosis. So first, when two solutions, two different concentration of the solutions, like one is the pure water and one more is the sea water. So these two water concentrations will be the different. These two different concentrations of the solutions are separated by the semi-permeable membrane. So this is we are called as semi-permeable membrane. Semi-permeable membrane. So one is the sea water and second one is the pure water. So these two are separated by this our semi-permeable membrane. First, the solvent flows from the lower concentration to higher concentration is called as osmosis. The solvent flows from this lower to higher is called as osmosis. When pressure is applied, this pressure is developed on the membrane. It is called as osmotic pressure. It is called as osmotic pressure. So when it is applied this osmotic pressure, it's 15 to 40 kilogram per centimeter. Okay, so this type of pressure, this much of pressure we can apply. This pressure we are called as osmotic pressure. So this osmotic pressure whenever we applied on this membrane, so concentration side, it is nothing but concentration side, then the solvent flows from the reverse direction. That means higher concentration to lower concentration. Higher concentration to lower concentration, then lower concentration to higher concentration. We can observe the solvent particles from this our reverse osmosis process. So first, the solvent flows from this lower concentration to higher concentration is called as osmosis. Then solvent, when hydrostatic pressure is applied, the solvent flows from this our higher concentration to lower concentration. It is called as reverse osmosis. So this is one of the method for this our desalination. Then removal of all the salts ions from this our water. Then this process we are using this semi-permeable membrane. So removal of all contaminants with the help of this semi-permeable membrane. So this semi-permeable membrane, it is made up of cellulose acetate or polymethyl acrylate or polyamide polymers. Then whatever we have to use of this our semi-permeable membrane, then removal of salt from this water. So almost all the removing of the contaminants, all the separate of the contaminants from this water So this type of filtration, it is also called as super filtration or hyper filtration. Whenever we are using this our semi-permeable membrane in this reverse osmosis process, then all the ions, all the salt ions, Na plus ions can be eliminated, or contaminants can be eliminated from this water. This filtration, it is called as super filtration or hyper filtration. What are the advantages of this our reverse osmosis? This is very simple and very easy to set up, and without any using of the chemical agents, and operating expenses, it is also the very less. And semi-permeable membrane lifetime, it is also about the 2 years, and very easy to replace of this our semi-permeable membrane. Within few minutes only we have to eliminate it of this our NaCl ions or salt ions or contaminates from this our water, and this water can be supplied to this our domestical and industrial purpose are also, or majorly we are using this water for this our drinking purpose. So we can getting of the purity of the water from this our reverse osmosis process. This is our engineering chemistry, water and its treatments, last topic we discussed in this session. Thank you one and all. Thank you all of you.